we will solve some numericals and answer some few questions. Okay. So the first numerical is, if bromine atom is available in the form of, say, two isotopes, 7935 bromine 49.7% and 8135 bromine 50.3%. So calculate the average mass of bromine atom. Okay. So first we will write the given values. The given values, I will write it in a tabular form. It is easy to follow. So isotope bromine, everything is bromine, so I write isotope here, occurrence and mass. So I will name the first one as isotope 1, second one as isotope, this is isotope 1, this is isotope 2. So the first one is, let me write the 7935, the second one is 8135. Okay, so these two are isotopes because atomic mass is same, sorry, atomic number is same, mass is different, so it has got different neutrons. Now the occurrence is also given, that also highlight. The first one is 49.7%, second one is 50.3%. The mass of the first one is, this is the mass 79, and the mass of the second one is 81. All these values are enough to calculate the average mass of bromine. Let me write the equation, that is mass of isotope 1, I will put a flower bracket for this, into percentage of occurrence. Okay, that is the first one. Because the two are there, so we have to take average of two isotopes. The second one also, let me write mass of isotope 2 into percentage of occurrence. Okay. Now substitute the values. Mass of isotope 1 is 79. The percentage of occurrence is 49.7. I'll write the full here, means in terms of percentage. Here in terms of percentage, I'll put 100 here, put a bracket, plus next one is 81, mass of the isotope 2, into percentage of occurrence is 50.3 by 100. So it is so I'll calculate the values separately. So here are the calculations. So 49.7 into 79, you do the multiplication, you will get 3926.3, 3926.3 by 100 plus 50.3 into 81 will give you 4074.3, 4074.3 by 100. If you add these two, you will get 8000.6 by 100. Okay, then it is 80.006 U. So this is the answer. This way you have to calculate. You have to take the average and then this much calculation you have to do it. Okay. Let us go to the second question. The average atomic mass of a sample of an atom X is 16.2 U. So the here average mass is given. What are the percentages of isotopes 16.8x and 18.8x in the sample? So the element name is, our symbol is X, and its mass is given and its isotopes are given. So we have to calculate the percentages. Okay. So let us again, like earlier, the given values are same way I will write isotope occurrence and mass. So isotope 1 and here the average atomic mass is given, average atomic mass. So isotope 1, isotope 2, isotope 1 is 16.8x, other one is 18x8. So it is an isotope because atomic number is same and masses are different. Occurrence we need to find. The masses I will write. Here it is 16U, this is 18U. Okay. So the average is already calculated, that is available, that is 6.2U. Okay. Okay, that way you can put this also U, it is okay, 6.2U. All are unified mass only. Then we will write the same equation. So here we cannot straight away apply this this formula because we don't know the percentage of occurrence that we need to find. So what we have to do, we have to assume. I'll assume the occurrence of isotope 1 as percentage Y. Okay. Then isotope 2 will become, see, is a percentage, so it is 100. This will become 100 minus Y. We will go back to the earlier problem. See, if this is 49.7, because both are for the 100%. So this one actually, if you subtract this from 100, you will get this value exactly. That is how you have to write this assumed values. The Y is the occurrence of isotope 1. The isotope 2 is 100 minus Y. Other way also you can write. You can assume this value and you can write this value as 100 minus Y. Okay. Then I will avoid writing this equation. Same equation I will follow here also. Okay. The average mass of element X. Okay. Straight away I will apply. I cannot show both together. Okay. You know it. Mass of isotope 1, 16. Occurrence of isotope 1, Y. The second one is mass of isotope 2 is 8. Its occurrence is 100 minus Y. So I will put one more bracket. Okay. Percentage. So I will put 100 here straight away. Okay. Or for clarity, this we assumed it as percentage. Okay, so you can put this. Now expand this. This will become 16y by 100 plus 18 into 100 minus y by 100. So I'll put everything together. 100 16y plus 1800 minus 18y. If I expand this, so further 16y plus 1800 minus 18y whole divided by 100. So 16 minus 18. So first I will write this value 1800. 16 minus 18 minus 2y by 100. This side I have to fill it up. This value is given, so no worries. 16.2 equal to this value. So now I will cross multiply this. Then 16.2 into 100, this into this, equal to 1800 minus 2y into 1. So it will become 1800 minus 2y. So this is 1620 is equal to 1800 minus 2y. Now 2y I will bring here, this I will take it to that side. So 2y is equal to 1800 minus 1620. So this will be how much? 180, correct? So therefore y is equal to 180 by 2 is equal to 90%. 90 value, so it is 90%. Our value is 90 only. Okay, overall let me not put here. Later we will put because we are calculating only y. So 90. So what about this is? So this is here we can put percentage because 90% here percentage I have put. Here, this one is 100 minus y. So 100 minus 90 is 10%. So these two are the answers. That is, isotope 1 is 90%, isotope 2 is 10%. Okay, this way we have to solve this numerical. So multiple choice questions. Question number 1. Why do most of the elements try to participate in chemical combination? So let us read the possibilities. To give more electrons, to achieve inert gas configuration, to complete their octet, to complete their inner shells. See, to gain more electrons, this we never discussed. This is not correct. To achieve inert gas configuration, correct. We have seen in the periodic table, the end, it will try to achieve that configuration. To complete their octet, yes, this is equal, this is the same. Meaning is same. To complete their inner shells, rule is different. Inner shells it has to complete to go to outer shells, but this is not the criteria here. So 2 and 3 are combination is correct. So not this. B is correct. Other things are not correct. Okay. Which of the following pairs are isobars? For isobars, atomic mass is same and atomic number can be different. Should be different. Okay. It cannot be same. So isobars, remember. So I am not showing the definition, but you please recollect it. So mass same, but number is different. Not this. This one, this already we studied, you remember, argon and calcium. No, here see mass numbers are different. This is also not correct. So B is correct. What property of an element determines its chemical behavior? Size of an element? No, straight away we can cut it. Valency of an element. So in valency chapter we studied only that valency is important for chemical behavior. Molar mass of an element. You studied molar mass in the earlier chapters. Molar mass is not important. None of this above is, none of this is not correct. So the correct one is B. Okay. Valence of an element is the deciding factor for the chemical behavior. So 4. The maximum number, I missed it. The maximum number of electrons that can be accommodated in a shell. N is equal to 3. So N is equal to 3 means what is the equation? 2n square. 2 into N is here 3. 3 square. 2 into 9. 18. So 18 is correct. Remember this equation. The number of